Hello everyone. In this session we're going to review the OSI model. The OSI model is a model that has been used for many years by network engineers, by system admins, by IT techs, um, any group that's or anyone that's been involved in information technology has probably heard of the OSI model or has had to understand it in order to either design a network or troubleshoot a problem in the network. And so we're going to look at the different layers today and try to use the slide in the labs as well to kind of get a better perspective of how these different layers operate within the network. The first layer of the OSI model is the physical layer. And this particular layer is mostly focused on like the physical mediums, how it sends unstructured bits from point A to point B through the physical medium. So in this particular layer, the physical medium would be like the cable that connects this particular PC1 to the switch. So in most networks, PCs connect using a copper cable. So basically, here's some examples of the physical layer, which is physical structure like cables, hubs, etc. So here's some examples. Here's an example of a Cat5 cable. He has copper wires in here, and so if this was a Cat5 cable, this would be a straight through cable, and it uses copper. That is the medium, and it uses electrical signals to send the raw bits through this wire. So this is what the physical layer focuses on: understanding and setting standards at the physical layer. For example, here you have a connector, and this connector has this cable in a particular order. The cables are in a particular color coded order, and because there's been a standard set at the physical layer of how these wires have to be ordered in order to be able to successfully transmit these bits from point A to point B. So through this wire here. These are also the connectors here that are used at the ends of the cables. Now there's other types of physical cables, like for example fiber, which actually uses glass. So you have like single mode fiber and multi-mode fiber. You can see here these ends here are not copper, but they are actually, it's fiber, it's glass. So the physical layer, this is where there's multiple standards on the types of connectors, the type of fiber, the type of ends. So there's different types of ends that you can use when you do fiber. For example, here you have a square connector, right? So this is what is called a square connector. This is an LC connector. So you have different types of connectors, even though it's still fiber, but you have different types of connectors. So that's what the physical layer is concerned with, the physical medium. And so when you're taking your exam, or if you're studying for an exam, for example, your CCNA, some of the questions that they'll ask you is, what is the standard to create a straight through cable or a crossover cable? And so those are standards that are set up at the physical layer. So you can have a straight through cable which connects from a PC to a switch, right? And if you look up that standard, it'll tell you exactly how to wire these cables in what order they need to be. And you need to know the difference between a straight through cable and a crossover cable, right? And the crossover cable is something that you would use when you connect like two switches together. You would need to use a crossover cable in that case. The next layer is the data link layer. The data link layer provides error-free transfer of data frames. So one of the things about when you talk about the data link layer, you're always going to talk about frames. And in a frame, it's always going to contain MAC addresses. And so basically the data link layer provides air-free transfer of data frames from one node to another over the physical layer. So at this point we're talking about MAC addresses. So frames is key. This is a key word when we talk about layer 2. We talk about frames. And basically frames are envelopes that contain layer 2 MAC addresses. So at layer 2, switches, when they operate at layer 2, they learn MAC addresses. So for example, in our lab here, if this PC1 wants to talk to PC2, it'll go to the switch, and the switch will create a MAC address table. That's where layer 2 comes in. So if we bring up our lab and we bring up our computer, right now this computer has a MAC address of 6802. So this is the MAC address, and it ends with 6802. This computer also has a MAC address. This computer ends with 6806. So one thing to know about layer 2 addresses is that every machine in the world has a unique MAC address. So there's never going to be two machines with the same MAC address. They'll always be unique. And so what the switch does when it's operating at layer 2, for example, this particular local LAN switch, it begins to learn MAC addresses from these machines. And the MAC address is assigned to the NIC. So every computer has a NIC, or network interface card, and that network interface card has a MAC address, or they call it the burned in address, because that MAC address is integrated into the hardware, the network interface card, whenever it's manufactured. And there's no other computer that has that MAC address. And so the switch will learn those MAC addresses. So if we look at our switch here and we do show MAC address table, we can see right now that the switch has not learned these two MAC addresses. But if we were to ping between the two switches, say for example, this PC has IP address 192.168.200.3, and this machine has 192.168.200.2, we're just going to ping between these two machines here, and that's going to basically initiate a packet from this computer to go up to the LAN switch and then down to this PC. Initially, because the switch doesn't know about any MAC addresses, doesn't know the MAC address of PC1, when PC2 sends a ping, the switch is going to send a broadcast packet throughout all of its ports. It's going to send a broadcast packet to all of the interfaces on the switch, and it's going to wait and see who responds back with that MAC address. So if we were to do a ping, and we're going to ping the IP address of PC1, we get a response here. This is the IP address PC1, and we do show MAC address table. Now we can see the two MAC addresses. So the MAC address table is very helpful when we're trying to troubleshoot a problem when one PC is not able to talk to another PC. Or even, say for example, if this PC was actually a printer and this PC is not able to talk to the printer, one of the things that we will want to do is to make sure that the switch is learning the MAC address of the printer. And so in this case, we have two computers on gigabit 01, which is gigabit 01. We learned this MAC address that ends in 6806, which in this case is going to be computer number 2 which is it ends in 6806, and then in gigabit 00 we have PC1, which ends in the MAC address ends in 6802, and we can see here 6802. So the switch is learning these MAC addresses, and so now whenever this computer wants to talk to this computer, the switch is just going to send the packets from here straight to here, because it knows where that MAC address is. It knows how to send that packet to computer 1. So that's what layer 2 is. Layer 2 focuses on MAC addresses. Layer 3. So layer 3 is the network layer. So the network layer controls the operations of subnets, deciding which physical path the data takes. So in our network that we have here, our network topology, the local LAN, this switch here represents layer 2. And then layer 3 operates at the router layer. So when we talk about the network layer, that's where we start introducing IP addresses, or in this case, the operation of subnets, right? So at layer 3, the main key word here is packets, right? So layer 2 was frames, which only has MAC addresses. And layer 3, we introduce packets, and packets that contain IP addresses. And so we can think of layer 2 as the envelope and layer 3 as the letter inside the envelope, and this contains the IP addresses, and this happens at the router layers. So the router at this point will introduce IP addresses. So when we work with computers that are in different networks, one of the important things to always make sure is to make sure that the computer always has the correct default gateway, because when a computer wants to talk to another device that's not within the same subnet or within the same network, it needs to go to its default gateway, or in this case the router, which will be able to make a routing decision based on the routing table. So when we look at a computer, when we look at PC1 and we do show IP, we can see that it has a gateway. In this case, the gateway is 192.168.200.1, and so the gateway is the router here. And so it's important whenever we're trying to understand the network layer, is when we start talking about IP addresses and how we can communicate between networks. So in this case, on this particular router, this router only has one network right now, and that's on this interface gigabit 02, which is right here. So all of this here, everything below this router is considered one network, because everything is inside this subnet. So if we look at the interface, we can see that this particular interface has an IP address of 192.168.200.1, which is the gateway for the computers. So basically, if this computer wants to talk to any device that's not part of the 192.168.200 subnet, it has to send it to its router, which is the gateway. The gateway is basically the central system that learns about different subnets and will be able to make that routing decision or make that connection between two different networks. So say for example, if this computer wanted to get to a network that's that doesn't exist, that's not part of the 200.1. So if we were to do ping 192.168, let's say for example 100.10, okay, so right now it says destination host is unreachable because there's no such network 192.168.100 inside this area here. But on the router, if we were to create that network, so for example, we create a loopback and we assign an IP address 192.168.100.10.255.255.250. So basically we're creating a network. So if we look at our interfaces now on this router, so now this router has two networks. It has the 192.168.200 network and the 192.168.100 network with the IP address of 100.10. So now if this PC wants to ping that IP address, it should respond. It's responding because now the computer is sending the request up to the router, and the router says, okay, I know how to connect to that different network, and it makes the connection. So that's what layer 3 is. Layer 3 is the network layer, and its focus is about IP addresses. And there's a lot more to layer 3, but in this particular session, we're just kind of trying to understand what we work with at each layer. Layer number 4 is the transport layer. And so the transport layer, basically what it does is that it ensures that messages are delivered error-free in sequence and with no loss or duplications. So the transport layer is what we look at, for example, TCP. So TCP operates at the transport layer, and so TCP has a mechanism of sequence numbers in order to ensure that packets are delivered successfully from one host to another host. And those sequence, for example, when we look at TCP, at this particular transport layer, there's different types of protocols that we could use. For example, we can use UDP and TCP. Those are the two main ones that we work with when we're talking about the transport layer, about sending data from one host to another host, and trying to prevent duplications. And TCP is the best one because you have TCP, which is reliable. It's a reliable protocol. And then you have UDP, which is unreliable. And so when you work at the transport layer and you're trying to get data from one host to another host, you can either choose TCP, which is reliable, or you can use UDP, which is unreliable. And now there's benefits. They both have their cons and pros, right? TCP, because it's reliable, you tend to use it more for, applications that are not sensitive to data loss, because it has the ability to handle errors, where with UDP, sometimes you don't care if you have an error or you have a packet drop. You just want to get the data across the network from host A to host B, and UDP kind of minimizes the number of checks in order to expedite the delivery of those packets. So in TCP we have the sequence. One of them is, like, for example, the three-way handshake. So this may be something that we can go into more details further down the line. But TCP is basically the most common protocol used at the transport layer to get packets from host A to host B. The next layer is the session layer. So the session layer is basically all sessions established between processors running on different stations. Okay, so when we come to sessions, we introduce the logical ports. And so when you set up a session on your computer, on your Windows computer or let's say a server, there's always going to be lots of sessions happening. Every connection that you initiate, say for example, from your computer to you create a telnet session, or you do an SSH session. So those are all unique source and destination ports, and they create a logical session, and they're using logical ports. And so that's what the session layer is focused on. It's establishing it's established between processes running on different workstations. So for example, you can initiate a copy session. Say for example, you want to transfer a file from host A to host B, and you start using, say for example, you want to transfer those files over FTP. Well, you can transfer multiple files at the same time because it creates multiple logical sessions. So you can initiate multiple sessions to expedite the file transfer, but that connection between host A and host B to get the traffic across, it uses unique ports, and that's where each unique port creates its own session. So you can have a telnet session and an SSH session open at the same time between two devices because they both use unique ports. They both have their own ports, so you can create multiple sessions. And so that's something that's very common to do, to expedite a process, or to accelerate a download, or to accelerate an upload. A lot of the applications today, FTP applications, web browsers, they instantiate multiple sessions to expedite or to process data faster, send data faster from one host to another host. So this is the session. So in this particular layer, we introduce ports. And so if you're going to be studying for your CCNA or Network Plus, understanding these ports is key, because there's gonna be multiple situations where you'll get asked what applications uses what port, and there's some very common ones that you're expected to know. Say for example, if you're using web, what is common for the web. So here we go, the World Wide Web, HTTP port 80. Port 80 is very common to use, to surf the web. And now HTTPS, is the most dominant one, which is port 443, right? So understanding and knowing the different ports is important, because sometimes you have to troubleshoot different applications, and they all use different ports, and they have their own sessions. So understanding the different ports, and understanding that when we talk about logical ports, we're talking about the session layer, is important. The next layer is the presentation layer. The presentation layer formats the data to be presented to the application layer. It can be viewed as the translator of the network. So basically, the presentation layer is taking all of the bits, all of the binary information, and presenting it in a way that the computer understands. For example, these are some of the different types of you can think of it as different formats, right? So different file formats. So we have like the JPEG format, the PNG format, the doc. These are all different formats, and so these are all different syntax that the computer has to understand, and all of that happens at the presentation layer. So it's basically a format that is used to present this information once it's received from the network over to the computer. the presentation layer. The very last layer is the application layer, and serves as the window for users and application processes to access network services. So the application layer is what's in front of us, right? So it's what we as the user interact with. So some of those are programs that that open when we're on our computer. Say for example, email. This is an application that we use to communicate, and so to us it's a nice GUI, it's a nice presentation, and we interact with it. And when we send the email, it goes down through the 7 layers of the OSI model, and we don't really see what's happening behind the scenes, but we have a interface that we interact with, and that's what the application layer is for. And so here's some examples of different applications that that we interact with our computer. Here I provided a link on how to find the information that I referenced in my PDF file here. So just to summarize, the OSI model is composed of 7 layers: the physical layer, the data link layer, the network layer, the transport layer, the session layer, and the presentation layer, and the application layer. I hope you find this video, this training session helpful, and hope to see you on the next session. Thank you.